Good morning, all of you. And here is a problem from Parabola. This problem is inspired by previous J advanced question where they have asked number of lattice point inside a triangle. Okay, so let's start the problem. Suppose PQR are lattice point, that is point with integer coordinates. So 1 comma 2 is lattice point, but half comma 2 is not. In the plane such that Q and R lies on parabola y equals x square, PQ and PR are tangent to parabola, let n be the total number of lattice points on the sides of triangle PQR, including the vertex. Find the area of triangle PQR. Okay, so first let's comprehend the problem. So we have a parabola y equals x square. It's always better to draw the rough picture. P and Q are lattice point here. So let's call point P and point Q as follows. Now we draw tangent at P, tangent at Q, and let's say these tangents meets at a point R. We need to find number of lattice point, number of points with integer coordinate on this triangle P, Q, R. Let's say the coordinate of point P be a comma a square and coordinate of Q is b comma b square. So now you can clearly see the equation of line PQ, the slope of line PQ MPQ is going to be a square minus b square by a minus b, which is a plus b. Since a and b are integers, since a and b belongs to integer, so z2 means z cross z, a is integer and b is integer. Okay, hence I can tell if the x coordinate of any point on line PQ is integer, the y coordinate has to be integer. The reason being very obvious. The equation of line PQ, if I see PQ equation, it's y minus a square equals a plus b into x minus a. So from here you can clearly see if x coordinate is integer, if this guy is integer, since a and b is already integer because p and q is lattice point, so y has to be integer, right? Y has to be integer. And that's a great news because now we can actually count number of integer point on line PQ. Since point P is integer and Q is having x coordinate integer, so the number of point is nothing but b minus a, or I can tell a minus b plus 1, right? The reason being, let's say if you have a point minus 1 comma something, and here we have 2 comma something else, right? So we have points as minus 1, 0, 1 and 2. So total number of integer points is 1, 2, 3, 4, which is nothing but 2 minus minus 1 plus 1. So this gapping plus 1, right? So I can tell the number of integer point that I am having is a minus b plus 1 on the side PQ. This includes vertex as well, right? Okay. Now again you can see on the segment PQ, the number of integer point will be same as the number of integer points having x coordinate, right? Because corresponding to this point, let's say P1, P2, P3, P4, P5 and so on, corresponding to P1, I'll get the same x coordinate because x coordinate of this point will be same as x coordinate of point P1. Similarly, P2, if I drop vertically down, the x coordinate of this point will be same as x coordinate of P2 and so on. Now I'm claiming the y coordinate will also be integer for these points which is lying on the segment PR. The reason being again obvious because the slope of tangent at point P, so y equal to x squared, the slope dy by dx is going to be 2x. So at point P, the slope of line will be 2a. So since the tangent line at point P is having again integer slope, so the equation will be y minus a square is 2a times x minus a. So again, if x coordinate is integer, y coordinate has to be integer. So from here it's easy to count the number of point with integer coordinate, and the same argument goes for segment QR as well, right? Because the slope of tangent at point Q is 2b and the equation will be y minus b square equals 2b times x minus b, and if x coordinate is integer, y has to be integer. It means if I go vertically down here, all these points must have lattice coordinate. Okay, now even that corner point will be taken care of by this. Vertically down you go from some point pk, it's taken care. So now how many points will be there on these two sides? It's same as number of points exactly between p and q, right? Because corresponding to any point I can create a bijection. I can go vertically down and there exists a point. So here number of points will be 1 2 3 4 5 in the diagram. It means total number of points is now a minus b plus 1, right? For example, if you start with minus 1 to 2, so now the number of points 2 in between 0 and 1, which is basically it is 2 minus 1, 2 minus minus 1, 3 and minus 1, right? So now the number of points on PR and QR, on PR union QR, number of lattice point here will be a minus b minus 1, right? So now total number of lattice point on this triangle PQR, because on PQ including these two vertex, the total number of points that I got is a minus b plus 1, and on these two segments excluding the vertex we are getting a minus b minus 1. So number of lattice point n comes out to be 2 times a minus b, right? And now we need to find the area of triangle PQR. Now finding area is not very difficult because point R we can calculate at the point of intersection of tangent at point P and point Q. And point R in a standard fashion, you know, either you can find the intersection of tangent or you can take point R to be, let's say, alpha comma beta. With respect to point R, write the chord of contact of this parabola, which is t equal to 0, since we are acquainted with coordinate geometry, and this compare with this line. By comparing you will get the arc coordinate will be arithmetic mean of p and q, which is a plus b by 2, comma y coordinate will be geometric mean, which is ap. So now we have 3 points, a comma a square, b comma b square, a plus b by 2, comma ab, right? So we have point P, point Q, point R. With these three, using Soule's formula, or we can find the area of triangle half times that of 1a square, 1b square, and 1c square. So we have 1 a plus b by 2 and ab, 1x1 y1, 1x2 y2, 1x2. Now you can subtract this equation and evaluate determinant. So that part I'm not going to do. By evaluating determinant, the area of triangle formula comes out to be b minus a whole cube by 4. Okay, so if we'll take magnitude of this again, the second symbol is magnitude, first is that this comes to be half times a minus b whole cube by 2, which gives mod of a minus b whole cube by 4, b minus a. Since a is more than b according to the diagram, so n a minus b value can be written as n by 2, so that becomes n cube by 8, 8 into 4 is 32. And that's a very surprising result, because you can see area of triangle just depends on number of lattice points. So delta is n cube by 32. So if area is known, I can find the number of lattice points, right? Since n was the total number of lattice points on the side of triangle PQR, so area is n cube by 32. So let's say if total number of lattice point n is 4, then the answer for area of triangle will be 4 cube over 32. So that gives you answer as 2. Right. So in this way, questions can be framed and asked. So this was a very good problem on basics, and see how I have used the fundamental idea of equation of line and equation of integer coordinate to build up this question. Thank you. Have a good day.